Hello everyone, let's go ahead and take a look at classifying shapes or classifying polygons. Now, what we can do if we want to classify polygons is we can go by the number of sides that the polygon has. So the simplest shape that we can have is a three-sided polygon or a triangle. Now, when we deal with a triangle, we can always go ahead and talk about three different types of triangles based upon whether the lengths of the sides of the triangle are all different, some are the same, or all of them are the same. And we call them these. We call the three-sided polygon or the triangle a scalene triangle if all three sides differ in length. Okay, we call a triangle that has two sides that are the same length, we call that an isosceles triangle. And if all three sides have the same length, then we call that triangle an equilateral triangle. Now, the things that we want to go ahead and also keep in mind is that if we go ahead and talk about a scalene triangle, which has three sides all in different length, then of course the angles also differ in size, and there's no angle in the triangle that has the same size. As opposed to the isosceles triangle, and notice the similarities here, if we have two sides that are the same length, then the two angles that are opposite the equal sides are also equal in size. When we talk about an equilateral triangle, the three sides, of course, all have the same length. And the nice thing is that all three angles also have the exact same size. And therefore, we can call an equilateral triangle an equiangular triangle as well. Now, an important thing about the equilateral or equiangular triangle is that if we have a polygon that is equilateral and equiangular, then what we call that type of polygon, we call that type of polygon a regular polygon. Okay, so let's go ahead and take a look at a couple of initial statements that we'll have for this particular section. And one of them is the sum of the angles of a triangle is equal to 180 degrees. The other one that we have is that an exterior angle of a triangle is equal to the sum of the opposite interior angles. Okay, so let's go ahead and make sure that we understand exactly how to apply these two initial statements. So say, for example, we have our equilateral triangle. Here's our equilateral triangle, and notice we said that being that it's an equilateral triangle, we also know that the angles are also equal in size. And so what we say is that all the angles are going to be theta. So what we can do then is we can say that, okay, here's our statement. I can say now that theta plus theta plus theta is equal to 180 degrees. And the reason for that is because I know that the sum of the angles of a triangle is equal to 180 degrees. So I know that theta plus theta is 3 theta, that's equal to 180 degrees. Divide both sides by 3 and I get theta is equal to 60 degrees. And sure enough, all of those angles are all 60 degrees, and therefore we can also call an equilateral triangle an equiangular triangle. Now let's go ahead and take a look at a similar case, this time with an isosceles triangle. So remember we said an isosceles triangle has two sides that are the same length. So we'll go ahead and say that this and this side here, both of which are going to be called the legs of the isosceles triangle, are the same length, S and S, and notice we have that marked there. Then what we say is that the angles that are opposite are also going to be equal in size. So let's just say that this angle here is 40 degrees, and we know that the angles that are opposite the equal lengths are also going to be the same size in terms of their angle measurement. Therefore, what we can say is that theta plus 40 is equal to 180 degrees. And the reason again is that the sum of the angles of a triangle is equal to 180 degrees. So if I take 2 theta plus 40 equals 180 degrees, subtract 40 from both sides, and I come up with 2 theta is equal to 140 degrees, divide both sides by 2, and I get theta is equal to 70 degrees. And the reason for all of that is just plain algebra. So what we can do then is, given this particular that particular angle, we can determine what the angles here and here would be. Now, we want to also go ahead and take a look at how to apply this one. Okay? Let's go ahead and take a look at how we need to incorporate just another piece of information for the triangle in order to deal with an exterior angle of a triangle. Now, if I go ahead and take a look at my isosceles triangle situation, if I was to go ahead and extend one of the sides past the vertex, then what I create is what is called an exterior angle to the triangle. So what I'll do then is I'll go ahead and call this exterior angle alpha. Now notice what happens is that if I go ahead and say alpha plus theta should be equal to 180 degrees, and the reason for that, of course, is that they are supplementary angles. So I know that theta, in our case, was equal to 70 degrees. So if I do a substitution for theta, I get 70 degrees plus alpha is equal to 180 degrees. Subtract 70 degrees from both sides, and I come up with alpha being equal to 110 degrees. Okay, so what that means then is that the exterior angle of a triangle we've just found here, it is 110 degrees. Now if I go ahead and take a look at the sum of the opposite interior angles, okay, so here is that exterior angle. The opposite interior angles to this one, here's that interior angle that's supplementary to that exterior angle. The interior angles that are opposite of that are these two. So if I go ahead and take a look at theta plus 40 degrees, and if I sum those up, I come out with 70 degrees plus 40 degrees is equal to 110 degrees, and sure enough, we've just shown that this is also true. Okay, so in addition to looking at triangles, we're also going to go ahead and take a look at quadrilaterals or four-sided polygons as well. So hang in there, just one second, don't leave. Alright, continuing with our discussion about classifying shapes or polygons, let's take a look at the four-sided polygons or the quadrilaterals. Now generally speaking, we have three different types of quadrilaterals. We have parallelograms, a trapezium, and a kite. And under the parallelogram, we have the rectangle, square, and rhombus. So let's go ahead and take a look at the parallelogram first. Here's a diagram of a parallelogram. Okay? It says it has opposite sides that are parallel. So notice the opposite sides are parallel. And the opposite sides are also equal in length. So this side is equal to that side is equal to that side in length. Notice that we also have the opposite angles that are equal in size. So this is equal to that angle measurement is equal to that angle measurement. The adjacent sides, notice, are not equal in length. So in other words, this side here is not equal to that side there. Now, that's going to be our most general case of what is called a parallelogram. Now, if we go ahead and add certain conditions to that, then we'll come across, say for example, a rectangle. Now, how do we go ahead and generate a rectangle from a parallelogram? Is that we just make sure that all the angles now are 90 degrees. So we have basically all of these angles here be equal to 90 degrees. If you can imagine what that's going to look like, then of course you come up with a rectangle. Now, think about a square. A square is going to be exactly the same thing as a parallelogram with the additional condition that all four sides are equal in length and all the angles are also equal to 90 degrees. So imagine that what we had, like say for example, if you had your rectangle, and notice that the rectangle doesn't have all four sides equal to the same length. If we make sure that all the lengths are also equal, then what we're going to come up with is a square. So notice that a square, being that it has four sides equal in length, it is an equilateral quadrilateral, and it is also have all angles being equal to 90 degrees, which means that it's also an equal angular quadrilateral, and therefore the square is our regular quadrilateral. Let's take a look at a rhombus. A rhombus is going to be the same as a parallelogram with all four sides equal in length. So imagine that it's kind of like the square again, right? Except for if we started off with the square, which is also all equal angular, that's not going to be a rhombus unless we go ahead and shift it a little bit so that basically what we have are all the angles not equal to 90 degrees. But it would still be the case that those angles that are opposite of each other would actually be the same in measure. Okay, so those are the parallelograms and the more specific types of parallelograms that you have based upon their additional conditions. Now, a different quadrilateral is going to be the trapezium or the trapezoid, and what we have is one pair of parallel sides. So here's two examples of trapeziums. Notice they're quadrilaterals with four sides and only one pair of parallel sides. Now, if the two legs which join the parallel sides are equal in length, then we call that an isosceles trapezoid, which is very similar to what we looked at when we talked about the triangle. So if this length right here and this length right there are equal, then what we have is an isosceles trapezoid. And again, very similar to the isosceles triangle, the angles that are opposite are going to be equal in measure. Now the last one that we're going to take a look at is the kite. The kite is going to be a quadrilateral with two pairs of equal sides which are adjacent to each other. So notice that what we have here is we have two pairs of equal sides, and again, it's similar to this, there's two pairs of equal sides, but the difference to this is that those equal sides are actually adjacent to each other and not opposite of each other. And so this is how you would go ahead and define a kite. Now, the one initial statement that's going to be very important for us with regards to quadrilaterals is the sum of the angles of a quadrilateral is equal to 360 degrees. And we saw that because if we go ahead and say, for example, cut any quadrilateral into two triangles, well, we know that the sum of the interior angles of a triangle is equal to 180 degrees. So therefore, if we have two triangles which make up a quadrilateral, then the sum of the angles of a quadrilateral should be equal to 360 degrees. Now, let's just go ahead and apply that to this particular case here. Here's our isosceles trapezoid again. And let's just say, for example, that we're trying to solve for what this angle theta is. Well, I can very easily say that 2 theta plus 2 times about 120 degrees is going to be equal to 360 degrees, because I know that the sum of the angles of a quadrilateral is equal to 360 degrees. After that, I have 2 theta plus 240 is equal to 360 degrees. Subtract 240 degrees from both sides. I get 2 theta is equal to 120 degrees, divide both sides by 2, and I come up with theta is equal to 60 degrees. And that is all done by algebra. Okay, so just to wrap up, again, remember we talked about triangles, and we also talked about quadrilaterals, and we classified those polygons based upon the number of sides that they have. After that, we looked a little bit more in depth in terms of certain conditions that will yield us specific types of triangles or quadrilaterals, and we took a look at 3 different very important initial statements to help us actually calculate the measures of particular angles. So we'll take a look at some examples in class, and we'll go ahead and work through these, and we'll also make sure that we're writing things in that type of fashion as well. So see you in class. Bye-bye.